Hi, my name is John, and I'm going to demonstrate our proposal, which is called the Foreseeable Credential Stuffing Attack. Before I show you the demo, let me briefly talk about the compelling points of our work. First, the formal credential stuffing attack uses only one ID, one password pair from breached credentials, and tries to log in across multiple sites, so their accuracy solely depends on the breached credentials. However, our proposal generates samples by analyzing similarities between passwords using AI models. Therefore, our proposal is more accurate and intelligent. Second, the recent targeted password guessing attack creates a large number of samples, usually from thousands to millions. They show excellent performance, but they are not suitable in an online environment since it is one type of brute forcing attack. In contrast, our proposed method generates only 5 samples and showing even higher accuracy than a targeted password guessing attack. Therefore, the proposed method is more efficient. This slide shows a diagram for a foreseeable credential stuffing attack machine. The machine consists of multiple AI models trained using total 3 billion passwords. Once the source is given, the machine checks the type of source and passes it to the designated AI models to generate samples. Let me show you on the demo page. This page is designed for only demonstration. By sliding the bar on the top, you can choose how many samples you want to generate from 1 to 10. But for today's demo, I will go with the 5 samples. Please see the table on the right. It shows how we create target password with the given sources. For example, if you give a lowercase letter as input, our machine detects its type and creates 4 types of target passwords. Here's one example. I will type David. Prediction. And it generates 4 types of passwords. They look like so human-like created passwords. David Love, David Maria, and David 1988. This one looks like the year of birth. Now, I'll put David 23, which is a combination of lowercase letter and number. It creates 3 corresponding types of passwords. Now, I will show you a real-world example with an actual dataset. All these passwords in the table came from collection number 1. On the one hand, most of them look quite strong since they chose good combinations of lower and uppercase letters, numbers, or symbols. However, if I show you their previous password together, I'm sure that none of you would say they look secure. All of them came from the same dataset, and we gathered them by analyzing similarities using mathematical algorithms. And here's the main point of my work. If you ever reuse or recycle your previous password, it can be cracked in few seconds, even if the password is long and complex. A large set of data with patterns can be a simple quiz to today's AI. Now, I will put the password in the first column into our machine. From Buster to middle lines. Accordingly, our machine creates a targeted password with each possible type. As a result, we cracked 1/3 of the total 12 users. And you can also see that the generated samples are so close to the target password, even though they failed to give a correct answer. You can see this result in appendix. Moreover, you can repeat this process with the password in the second column. By doing so, we finally succeeded in compromising 2 more accounts. In addition, you can further narrow down the guessing samples for targeted passwords by checking additional domain information. For example, this is a sign-up page for Black Hat briefings. And when you set password, it must be longer than 8 characters consisting of upper lowercase letters and the numbers or the symbols. Thank you so much for watching this clip to the end. Based on this research, we are planning to release the new type of password strength meter that takes two inputs, an old one and the new one, and tell users how easy to break the new one if the old password had been stolen in the past, and encourage them to set a stronger password. I wish I could share more details with you at the conference. Thank you.